Alright, welcome to today's lesson on repetition structures. It will keep going and repeating itself, much like the Energizer Bunny. Ba-dum-bum. So today we're going to talk about the programming structures we've covered so far in the course, and then we're going to focus in on specifically the repetition structures that exist. Those are the counting loops and the conditional loops. So, normally, as we've seen before, code is executed line by line in the order it appears. But sometimes we want to change the behavior of our program based upon a decision that we've made, or we sometimes want to repeat sections of code over and over and over again. We have to do this by adjusting its flow using what we call programming structures. And as we saw before, there are three basic programming structures that exist. The first and most basic is called sequence, and this is the normal flow of a program where we execute code line by line, one line at a time, in the order that it appears. The second programming structure is called selection, and this is where we make a decision about whether to run a certain section of code or not based on a comparison of two or more values. And the third programming structure that we're going to talk about today is called repetition, where we repeat a section of code over and over again a certain number of times. And as I said at the beginning of the lesson, we have two types of repetition structures that exist. The first is called a counting loop, and this is going to repeat a set of code a specific number of times. So this is when I know the number of times I want to do something, I would use a counting loop. This is different from the second type, which is called a conditional loop. A conditional loop runs who knows how many times, but until we meet a certain condition. So it could run one time, it could run 1,000 times. We don't know the number of times it's going to run. It runs until something's true. So for example, I might have a game, and you could run it over and over and over again until you say you don't want to play anymore. So if I have an awesome game, you're probably going to run it like 1 billion times. And if my game is terrible, you might run it once and say this sucks and never run it again. So it would only loop once. Okay, that's a conditional loop. So we'll start by looking at the counting loop. And the counting loop has two sections. The first is the control statements, and the second is the statements we're actually going to repeat. The control statement is broken up into 4 sections. Okay? We have the first section, which is a variable that we call the counter. Okay, this counter variable is going to count the number of times that I have run my loop. The second type of information is the start value. So this is the value that my counter is going to start at when I do my loop. Then I also have the end value. That's going to be the value that I have to reach in order to stop my loop. Notice that it goes up to, but not including, this end value. And the fourth piece of information is the step value. This is the amount that I'm going to increase my counter by each time I pass through my loop. So again, here's the definitions that you can see. So the counter is the number of times my loop has been executed. It is a variable. The start value is the number that I'm going to start my counter at. The end value is the number I'm going to end my counter at. And the step value is the amount that I'm going to increase my counter by each time I go through my loop. So here's an example section of code. In this code, I've got a variable called number, and I've got a loop that is a counting loop. It's going to have a variable called index. This is the counter, and its index is going to equal 1 and go up to but not including 4 times, increasing itself by 1 each time I go through the loop. And each time I go through the loop, I'm going to run these statements here in orange. So now I'm going to give you a minute. What I want you to do is pause the video, run through this, and predict what you think the output of this code is going to be. Alright, when I try and predict the output of a code, what I do is I set up a table to keep track of the values of each of my variables. So I have a variable called number, I have a variable called index, and I also have my output. So I create my table, and then I'll be able to figure out what is going to be done here. So my number starts out as 1, my index also starts out as 1. The first time through the loop, my number is going to be equal to index times 2. So 1 times 2 is 2. So number is now 2, and I output a 2 according to this line of code here. I've now reached the end of my loop, so I go back up to the top. I'm going to increase my index by 1. So index now becomes a 2. Since 2 is less than 4, I'm going to run my loop again. So number is going to be equal to index times 2. 2 times 2 is 4, so I'm going to output my 4. I run back up to the top of my loop, increase my index by 1. So my index becomes a 3. Since my index is less than 4, I'm going to go into my loop again. So number is going to be equal to index times 2. Index times 2. 3 times 2 is 6. So that's a 6. I output a 6. I run back to the top of my loop, increase my index by 1. It's now a 4. But I'm going up to, but not including 4. So this is a 4, so I stop. My output ends up being 2, 4, 6. Whenever you see a question like this on a test, my advice to you is to create a table like this so you can follow through what the values of all your variables are, making sure you don't make any very simple or stupid mistakes as you figure out your output. The flowchart for what this counting loop would look like is as follows. I would have a process where I declare what my index value starting value is, and if that index value is greater than or equal to 4, so this is my ending condition, if it meets my ending condition, then I can continue on with my program. As long as it hasn't met the ending condition, I'm going to go into this section here where I'm going to do whatever I was going to do. So in this case I was multiplying my index times 2 and then outputting that value. I then increase my index by 1. So this is the step value. I increase by 1 and go check it again. I keep on repeating this until my index is equal to 4, in which case I finish my loop and continue on with my program. So a couple things about the counting loop. First of all, the index must always be an integer value. I cannot use a decimal number for my index. If I put a decimal number in, it will always be rounded down. So if I try and create an index of 5.9, it will equal 5. Secondly, the index must always increase in value. I cannot have my step value being a negative number. If I do that, it would never actually reach the ending value, making an infinite loop that would run forever. My counter would just keep going down, 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 never reaching the ending value. While infinite loops can be useful, generally speaking we want to avoid them because they can create a hang in your program, so it just sits there and does nothing forever and crashes essentially. We can also simplify a counting loop in Alice by showing just the number of times I want to repeat. If I don't like this format, just saying repeat it 6 times, I can show the complicated version that we saw in the example before. So, the second type of loop we talked about was the conditional loop. And this was the type of loop that we did not know the number of times we were going to loop. Okay? This is also sometimes called a while loop. When we do this, we're essentially going to test a Boolean condition, just like we did in selection structures. And if that Boolean condition is true, we're going to execute the code inside the while loop. If that Boolean condition is false, we stop the loop and we continue on to the next section of code. So what does this look like? So again, we have the while statement, which tells me that I'm going to be looping in a conditional loop. Then I have my logic expression, which is exactly the same as we had in our selection statements. And then I have the statements that I'm going to be repeating if this logic expression is true. So here's the example. Again, I've got a variable called number which equals 0. This case I'm using the while structure, and while my number is less than or equal to 8, I'm going to have my number set to 2 plus the number and output it. So again, pause, think about what the output you think is going to be, and then resume the video when you have your answer. So again, hopefully you've made your table. So there's my number. In this case, I only have 2 variables, so I've got my number and my output. Number starts off as a 0. May not be able to fit all this in here, but number was a 0. That's less than or equal to 8, so number's value is going to be 2 plus number, so number is now 2, and I output 2. Skip to the top loop. 2 is less than or equal to 8, so I go inside, and it's going to be 2 plus what it was before, so number's now going to be 4. I output a 4. Skip back to the top. 4 is less than or equal to 8. So I come back into this line of code. Number is going to be 2 plus number. So 4 plus 2 is 6. I output the 6. Skip back to the top. 6 is still less than or equal to 8. So I'm going to go inside here. 2 plus 6 is 8. I output 8. Scroll back to the top. 8 is less than or equal to 8, so I'm going to increase by 2 again. So 2 plus number is now 10. And I'm going to output 10. Scroll back to the top. 10 is no longer less than or equal to 8, so I stop my loop, my program is done. So I would have outputted 2, 4, 6, 8, and 10 in this particular example. If we want to see the flowchart for this, again, I've got my variable called number, given it a value. If that number is less than 8, I'm going to go into my loop and add 2 to it and output it. I keep on doing that as long as that number is less than 8. As soon as that's no longer true, I skip out of my loop and continue on with the rest of my program. That's it. Hopefully you've learned something about doing repetition structures. We'll see you in class tomorrow where we can practice what we've learned.